3, we're going to talk about scientific notation. So all scientific notation is just a different way to write numbers. So I'm going to introduce that first, and then we'll go to the first two problems. So at the very bottom of the page, we have scientific notation. So all it is just some number between 1 and 10, okay? And then we're multiplying that by 10 to some power. So when you're dealing with really large numbers or really small numbers, it's nicer to write something like -5 times 10 to the 8th power. And that's the same thing as 500 million, right? So we're just writing it in a more compact way. So this is good when we're dealing with really large numbers. And you can also have really small numbers, and it'll be helpful as well, because you can write it like this instead of having to write all those numbers out. Okay, so all we're going to do is basically just write things in scientific notation. So if I look at this first one, it says, according to the U.S. Geological Survey, the Himalayan mountains rise more than 1 centimeter per year. So it says, find the rate of the mountains rising in miles per hour. And then it says, is this speed small or large, and what's the rate? And then it says, find the sign of the exponent on the power of 10. Okay? So what I want is, the first thing I need to do is change it from centimeters per year. So we're doing a conversion from centimeters a year. And we eventually want to change that into miles per hour, right? So miles on the top and hours on the bottom. Okay. So I think that this is just like we did before when we were converting things. So I'm just going to give you the answer as far as how to convert these. And I'm going to say that to change from centimeters to miles, we need to divide by 1,000, or let me see, 16, sorry. So we need to divide by 160,934 to get from centimeters to miles. Okay. And you can find that pretty easily by changing miles into feet, and feet into inches, inches into centimeters. But I'll just keep it short since that's not part of the lesson today. So we're going to divide by this number to change centimeters into miles. And then we need to find out how many hours are in a year, right? So how can I start changing years into hours? Anybody know?
We know there's 24 hours in a day,
Mm-hmm.
and there's 365 days in a year.
Yeah, so I need to multiply by 365 days in a year, and then multiply by 24 hours, right? And then I know this is 1 centimeter per year. So on the top, we're going to multiply by 365, multiply by 24, and then divide by this number, right? And that'll change us into miles per hour.
And we get 8,760 for the hours.
Yeah. So on the top, we get 8,760 miles, and that's per 160,934 hours. Okay. So all we need to do to change that into miles per 1 hour is just divide those two. So I'm going to divide those two, and we get 0.0544 miles per hour. Okay. And what we need to do is change this into scientific notation. So what we need to do is we look at this decimal place. So we have this decimal place, and we want to make a number between 1 and 10. Okay. And the way we can do that is we can shift this decimal place to the right 2 places. Right. So then we get 5.44. So what I'm going to do is write 5.44, and I'm going to multiply that by 10. And if I shifted it to the right 2, I made this number bigger. So this 10 has to get smaller by 2 places. And the way I can do that is just writing -2 up here. Okay. So if I move to the right, however many places I move to the right is how negative this number is going to be. And however many places I move it to the left, so if I have a smaller number and I'm making it, or I have a big number and I'm making it smaller, this 10 to the whatever power is going to be a lot bigger. Okay? So if I have a negative, I'm dealing with small numbers. If I have a positive exponent, I'm dealing with big numbers. Okay? And then, of course, that's still in miles per hour. Okay? So that's our answer for this one. So the question is the speed a small or large rate? Well, we know that there's a negative up here, so it's definitely a small rate. And then it says, what's the sign of the exponent? Well, it's negative. So if it's a small rate, it's negative. If it's a big rate, it's positive. Okay, so if we've dealt with a small one, then the next obvious example is to deal with a big rate, right? So this one says we have 10,000 cubic centimeters, or cubic kilometers, right? And we want to convert that into cubic inches, okay? So the way we can do that is, and I'll give you the answer here. So you can multiply it by this number. Just want to make sure I wrote it down right. Okay, so my commas are a little bit off, but it should be, let me see, 61, looks like 61 trillion, I believe. Yeah, 61 trillion, 20 billion. Yeah, 61 trillion and 20 billion. Okay. So we're dealing with a really large number here, right? So when I'm multiplying something by 10, all I'm doing is just moving the decimal place right to the 1, right? Right, 1 place. So what I'm going to do here is I see I have this 10,000 number, right? So if I move this, or I guess how many times do I have to multiply 10 to get to 10,000?
100.
Yeah, so if I multiply 10 multiplied by itself, I have to do that 4 times though, right? Like this right here is 10 multiplied by itself 4 times.
Right.
So what I'm going to do here is I'm going to move this decimal place to the right 4 times. So I have to add a bunch of zeros, right? And now I have this huge number, right? This huge number, and it's in cubic inches. So it's in cubic inches. And I need to change that into scientific notation. So my question here is, what should this A be when we're changing it into scientific notation? So I know it has to be between 1 and 10, right? So the only thing I can do is move this decimal place, and it has to be between 1 and 10. So I'm going to move it all the way up to the front right here, right? So then I have 6.102, because this number is between 1 and 10, right? And then I can say that I can multiply this by 10 to some power, okay? And I know that I have a really big number, so I'm going to have a positive exponent, okay? And just to find out what that exponent is, I just have to see how many times I moved that decimal place. So it looks like I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I moved that decimal place 17 times. So this should be to the 17th power. And then if I multiply that 10 out, that 10 to the 17th, that's just the same as moving this decimal place to the right 17 places. Okay. And then it asks, is this the volume a small or large quantity? Well, it's definitely a large quantity. Okay. And then it says, what's the sign of the exponent? Well, it's a positive exponent. Okay, any questions on this page? Okay. All right, so we'll go to the next page then. So the next page will be a little bit easier. It's not as wordy as the last one. There's no conversions to do. So this one says determine if each number is in scientific notation. If not, explain why. So if I look at the first one, it looks like I have a number between 1 and 10, and it can be the absolute value as well. So we can have negative numbers between -1 and -10. Okay? And it's multiplied by 10 to some power, right? So this first one is in scientific notation. Okay. Is the second one in scientific notation?
No,
No. And why is it not in scientific notation?
because it's not a number between 1 and 10.
Mhm.
And it's also not times 10 to any power.
Right. So what can we change b to make it in scientific notation, at least for the number? So how can I change this to be a number between 1 and 10?
5, move the decimal point between the two fives.
Yep. So we just moved the
And-
decimal place to the left twice.
Yeah.
So then we're at 5.5 multiplied by 10. And what power should we have for 10?
-2.
So remember, this is a large number, right? If we make this number smaller, the exponent has to be bigger, right? So it's going to be a +2,
Oh,
right? So if we have a
Okay.
negative, it's going to be a decimal. So it's going to be like something like on the last page, we had a really
Right,
small
right.
decimal. If it's a whole number or a big number like that, it's going to be a positive exponent.
okay.
Okay, what about C? Is C in scientific notation?
No,
Why is it not?
79's too big.
Right, it has to be between 1 and 10, right? So what we have to do is move this one to the left. So we're at 7.9 multiplied by 10. And we made this number smaller. So 10 to the -4 has to get bigger. So what we're going to do is we're going to add 1 to the exponent. So it's to the -3rd. Okay. So if we make this number smaller, the exponent has to get bigger, and vice versa, right? So if this gets bigger, this has to get smaller. Okay. Okay. So if we look at D, we can tell this isn't in scientific notation because it's not between 1 and 10, right? So we're going to have to move this to the right one to get 9. So we get 9 times 10. And since this got bigger, this has to get smaller by 1. So we're at 10 to the 11th power. Okay. All right, so what about E?
You can't
Oh,
leave it as a 0.9.
So no, so it has to be specifically between 1 and 10 to be in scientific notation.
Okay.
Okay. All right, what about E? Is E in scientific notation?
Yes.
Yes, it is, right? So we have a number between 1 and 10, and we have it multiplied by 10 to some whole number power. So yes, this is. Okay. What about F?
Yes.
So we have a number between 1 and 10, right? And that's multiplying by 10 to some power. So this is one of our special cases where it's not in scientific notation. And the reason it's not is because we don't have a whole power for 10. So it
Okay.
has to be a whole power. So I'm just going to say no, and it's not a whole power exponent. So basically just meaning that it has to be a whole number up there to be in scientific notation. Okay. All right. What about the last one? Is the last one in scientific notation, G?
Yes.
Yes, it is, right? So we have a number between 1 and 10, and it's multiplied by 10 to some whole number power. Yep. So this one's a yes. Okay. So now that we've talked about scientific notation, we've converted from standard notation, which is just like writing out the number, to scientific notation. Now we're going to go backwards. So we're given a scientific notation, and we have to convert it into standard notation. Okay. So does anybody have any idea of how I can convert A into standard notation?
So we'll add 4 zeros to the end of 9.62.
Yeah, so all we're doing Absolutely, yeah. So all we're doing is just moving the decimal place to the right, and we're going to move it to the right 6 places, right? So that's just like adding 4 zeros at the end. So we're going to have, we write the numbers out, and then we add those 4 zeros. Yep. So we're at what? 9,620,000. So all we're doing is just moving the decimal place to the right 6 places. Yep. Okay. So we know that this is going to be a really big number because this is a positive, right? So we have a negative on the next one, so this is going to be a really small number. So what we're going to do is instead of moving it to the right, we're just going to move it to the left. And we're going to move it to the left 6 places, right? So 0.000000962. All right, and then this kind of confirms what we were looking at in scientific notation because it's a really small number. All right, anyone have any questions on this page? Okay. So I'm going to skip the how it works up here. It's just letting you know how to change between scientific and standard notation. But personally, I like doing the examples better. So, okay. So this one says convert 7 million into scientific notation. So if I wanted to convert that into scientific notation, when I multiply it by 10 to some power, is the power going to be positive or negative?
Positive.
Positive, right? Because we're dealing with a really big number. So what should my A be, or what should my number be?
7.
Yep. So we have 7 times 10. And what power should this 10 be?
6.
Yeah, because we're moving the decimal place to the left 6 times, right? So it should be to the 6th power. Okay. What about the next one? What should my A be? So I move it to the left 3 times, right? So we get a number between 1 and 10. So we get 5.257. That's multiplied by 10. And this is a big number, and we moved it to the left 3, so it should be a positive 3 for my exponent. Okay. All right. If I look at B here, or yeah, this next one, B, it says this is 0.5257. So I have to move it to the right 1 to get it between 1 and 10. So we're at 5.257. And I multiply that by 10, 2, and it looks like I moved it to the right 1. So this got bigger, so my exponent needs to get smaller by 1. So it's 10 to the negative first power. Okay. All right, and then if I look at my last one for C, it looks very similar to the one that we just did up here, but I'm multiplying it by 10 to the 7th power. And it looks like what's wrong with this one is my decimal isn't between 1 and 10, right? So all I need to do is just move this to the right 1. So we're at 5.257. That's multiplied by 10. So this got bigger. So my exponent has to get smaller by 1. So it should be to the 6th power. Okay. All right. Any questions on this page? Okay. All right. So now if I have this chart here, so we're just going to do the same thing like we've been doing before. So we have this chart, and we're going to change it between scientific notation into standard notation into words. Okay. So if I have this one in scientific notation here, I have 8.7 times 10 to the negative 4th. I know it's going to be a small number because I have a negative exponent. Okay. And how small it's going to be is determined by that exponent, right? So what I'm going to do is I'm going to move it to the left 4 places since it's a negative 4. So I'm going to have 0.00087 for my standard notation, right? And I'm not necessarily worried about the words here. I think I'll skip that for the ones that they ask. Okay, what about the next one? So we have negative 7 times 10 to the 0th power. So what is that in standard notation?
Mhm.
What do we think? What is negative 7 times 10 to the 0th power? So what is 10 to the 0th power?
Well, that would just be 10.
That's to the first power, right?
Oh, right.
What is anything to the 0th power?
Zero.
No.
1. It's 1.
1, right? Yep, anything to the 0th power is 1. So this just changes to a 1. So what's negative 7 times 1?
Negative 7.
Yep, so our standard notation is negative 7. Okay. What about the next one? Is this going to be a large number or a small number?
Large number.
Large number, right? Because we have a positive exponent. So we move the decimal place to the right 4 places. So we should have 87,560. Yep. Okay. So does anybody know how many zeros 5 trillion has?
12.
That sounds right, yeah. So I'm going to write out 12 zeros. Yeah, so that's, yeah. Yep, 5. Yeah, it should be 12 zeros. So we're at, so we're at 5 trillion. Okay. So that's our standard notation, right? So what should our scientific notation look like?
5 times 10 to the 12th.
Yep, 5 times 10 to the 12th. Absolutely. Okay, so if we look at this next one, we have 1 millionth. So that's going to be a really small number, right? And it should have 6 zeros. Yeah, it should have 6 zeros and then a 1. Okay. So that's our standard notation. So our scientific notation, if we move this over, we should have 1, right? And it should be multiplied by 10 to the 1, 2, 3, 4, 5, 6, 7 to the negative 7th power, right? Because we had to move that decimal place over 7 places. Okay, so our last number here, it looks like we have 3 quadrillion. So to write that in scientific notation, we just have to move the decimal place over. So we have 3 times 10 to the
15th.
Yep, 15th power. Okay. So we filled in that chart. It looks good. Let's do one more chart just to make sure we have it down here. So we introduced something new here called engineering notation. So basically what that is it's very similar to scientific notation, but we don't have the restriction of keeping a number between 1 and 10 for our A value. Okay. So
Why do what happens to why isn't there the restriction with engineering notation?
To be honest, I'm not really sure. I'm not an engineer, so I have no idea.
Awesome. Okay.
So I'm not really going to worry about engineering notation as much. It's not. I don't think it's going to be on any of your homework. It's just kind of an example problem. Same thing with the words here. I'm not going to worry about those. So we'll just fill in the standard and scientific notation.
Yeah, it wasn't on the 4-3 homework at all.
Yeah.
Either one of that.
Good. Thank you.
Yep. Okay, so for the scientific or the standard notation rather, how can we write 10,000 in standard notation? So how many zeros will we have? It should be
4.
Yeah, 4. Yep, 10,000. Yep. And then to change that into scientific notation, we should have 1 times 10 to the what power?
4th.
Yep, 4th power, because we have 4 zeros, right? Yep, absolutely. Okay, 16 trillion. So you'd have 16 and 12 zeros after that, right? Yeah. Yep. And then to change that into scientific notation, we should have what? 1.6 times 10 to the what power?
Oops.
Let's see, it should be 13, right?
Oh,
There's
because
12 and
yep.
one more. Yep, so 13th power. Okay. 421 thousandths. So that's what? That's going to be a small number. So we have 0.00421. Yep. Okay, so then we can change that into scientific notation. So it should be at 4.21 times 10 to what power?
-3.
Yep. So we made this bigger by 3, so the exponent has to get smaller by 3. Yep. Okay. How can we change this engineering notation into scientific notation? So how can I change this into scientific notation?
Make it 6.5
Mm-hmm.
and add 1 0 or 1.
1 to the
Wait.
exponent.
So 6.5 times 10
take-
to the 10th.
Take 1. No, take 2 away because you're moving it to the left, right?
So we're making this number smaller, right? So
Yeah.
this number has to get bigger. And we got smaller by 2 places, so this has to get bigger by 2 places. So it should be 10 to the 11th power.
I see that.
And then to write this in standard notation, well, we're going to start out with 6 and 5, right? And then we have to add 11 zeros after that. Or rather 10, right? Because we moved it 1 over already. So we should end up with, what, 650 billion. Okay. All right, so what about the last one? How can I change that into scientific notation?
9 times 10 to the 5th.
Yep. So I made this one bigger by 1, so this has to get smaller by 1. Yep. And then to change it into standard notation, we just have to add 5 zeros, right? So 9 and then 5 zeros. So we end up with 900,000. Any questions on this page? All right. Go on to the last page for this lesson. So this one, it says calculators with numbers that are in scientific notation can be done quickly and sometimes without a calculator by using exponent rules. So it says, for example, we're going to multiply these two that are in scientific notation. So all we need to do here is multiply the coefficients. So in this case, 3 and 4. And then we add the exponents. So we add 6 and 7 together. Okay. And then we might have to simplify it back into scientific notation. Okay. So I'm going to do these steps. I'm going to multiply the coefficients. 3 times 4 is 12. And I'm going to multiply that by 10 to the 7 plus 6 power, which is 13. Right? And then the last thing we need to do is write this in scientific notation. Right? And we know that it's not in scientific notation because we have a 12 out here. So it has to be between 1 and 10. So what I can do is move that decimal place 1 to the left. So we get 1.2 times 10 to the, and what power should it be?
It'd be 14 because we made that number smaller.
Yep, absolutely. So we made this number smaller, so we have to make the power bigger. Yep. So we get 1.2 times 10 to the 14. So that's how we multiply two things in scientific notation. Okay. Okay. So let's try that out with this one right here. So we have 5 times 10 to the 4th, and that's squared. So what I'm going to do is I'm going to rewrite this. And what I'm going to do is I'm going to have 5 times 10 to the 4th, and we're squaring it, so we're multiplying it by itself, right? So I'm just going to multiply this by 5 times 10 to the 4th. Okay. And then all we need to do now is just like we did up here. We multiply the coefficients, so 5 times 5 is 25. And then we add the exponents, so 4 plus 4 is 8. So we have 25 times 10 to the 8th power. And then we just need to change that into scientific notation. So I'll move this 1 to the left. So we have 2.5 times 10 to the 9th power, right? Because this got smaller, so that has to get bigger. Okay, so if these are the steps for multiplying two things in scientific notation, what do you think we're going to do when we have something when we're dividing by scientific notation?
I'm going to subtract the notations and
Yeah.
divide the numerator from denominator.
Yeah, absolutely. So we're going to divide the coefficients and we're going to subtract the exponents, right? So we have 18 divided by 3, which is 6, multiplied by 10 to the 12 minus 6 is 6. Okay? So we divide the coefficients and we subtract the exponents.